Right now, one object you see every single night is deciding whether your descendants live on a planet with stable seasons at all. It has been doing this for billions of years. It is doing it today, and almost nobody on Earth realizes how much depends on it. The strangest part isn't that it's happening. It's how easily we could lose it. There's no headline, no flash in the sky, no single night you could mark on a calendar. Just one quiet companion drifting a little farther away every single year, pulling on a tilt that keeps our entire climate stable. So let me show you the machine that has been protecting Earth's seasons. The machine hovering right above your head tonight. Start with a fact that should not be true but is. Earth's axial tilt, the 23.5-degree lean that gives us seasons, is not naturally stable. Left alone, a planet's tilt can wander chaotically over millions of years, swinging wildly between extremes. Mars does exactly this. Its tilt has swung between roughly 13 and 40 degrees over the last few million years, with nothing anchoring it steady. Earth should be doing the same thing. The physics says so. The simulations say so. And yet Earth's tilt has remained remarkably stable, drifting by only about 2.4 degrees over tens of thousands of years. For decades, nobody could fully explain why Earth was the exception. The answer turned out to be hanging directly above us the entire time. The Moon. Our Moon is unusually large compared to its host planet. No other rocky planet in the solar system has a moon anywhere close to this size relative to itself. Mercury and Venus have no moons at all. Mars has 2 tiny captured rocks, barely large enough to see as more than points of light. Earth has a companion roughly 1/4 its own diameter, locked in a stable orbit, exerting a gravitational pull strong enough to matter. That pull acts like a gyroscope, stabilizing the wobble of Earth's spin axis. Without the Moon's gravity holding it steady, Earth's tilt would likely drift chaotically, swinging between extremes that would make stable seasons, stable climate, and stable agriculture nearly impossible. This effect comes from lunar torque. The Moon's mass pulls on Earth's equatorial bulge, the slight outward swell caused by our planet's rotation, and that pull resists sudden changes in the tilt's direction. Think of a spinning top with a weight attached to its rim. The weight resists any sudden tip to one side, smoothing wobbles that would otherwise grow. The mathematics behind this was worked out in 1993 by French astronomer Jacques Lascar and his colleagues, who simulated how Earth's tilt would behave with and without a large moon. Without the moon, their models showed Earth's tilt could swing chaotically between roughly 0 and 85 degrees over millions of years. At 85 degrees, the poles would point almost directly at the sun for half the year each. Entire hemispheres would flip between permanent blazing summer and permanent frozen winter on geological timescales. With the moon in place, that wild swing shrinks down to the gentle 2.4-degree wobble we actually experience. The difference between a livable planet and a chaotic one comes down to the gravitational presence of a single companion, roughly 384,000 kilometers away. Here is the part that should genuinely concern you, once you understand it. The moon is moving away from us, right now, every single year. Using laser reflectors left on the lunar surface by the Apollo astronauts, scientists have measured the moon's retreat with extraordinary precision. It is drifting outward at approximately 3.8 centimeters per year, roughly the rate your fingernails grow. That sounds negligible on a human timescale. It is not negligible on a planetary one. The moon formed roughly 4.5 billion years ago, likely from debris thrown into orbit after a Mars-sized object struck the early Earth, an event scientists call the giant impact hypothesis. At that time, the moon orbited far closer than it does today, possibly within 20,000 to 30,000 kilometers, compared to its current distance of roughly 384,000 kilometers. Tidal forces between the two bodies have been pushing the moon outward, slowly, continuously, for the entire history of the solar system. As the moon recedes, its stabilizing grip on Earth's tilt gradually weakens. The gyroscope effect depends on distance, and distance is exactly what keeps increasing. Researchers modeling this long-term drift estimate that in roughly 1 to 2 billion years, the moon's stabilizing influence will weaken enough that Earth's tilt could begin wobbling more freely, potentially entering the kind of chaotic swings we see on Mars today. That is far longer than human civilization, likely far longer than our species itself. But it reframes something we take completely for granted. The stable seasons that allowed agriculture, that allowed civilization, that allowed every culture in history to plant and harvest on a predictable calendar, were never guaranteed forever. They were handed to us by a temporary alignment of gravity and distance, one that is quietly, gradually expiring. There is a second piece to this story, because the moon's influence is not limited to the distant future. It shapes our planet every single day right now. The tides. Ocean tides are driven primarily by the moon's gravity pulling unevenly on Earth's oceans, creating a bulge of water on the side facing the moon, and a second bulge on the opposite side caused by the difference in gravitational pull across Earth's diameter. As Earth rotates beneath these bulges, coastlines experience the rising and falling water levels we call high and low tide. Some researchers studying early Earth believe these tides may have played a role in the origin of life itself, repeatedly stranding pools of seawater along ancient shorelines, concentrating chemicals through evaporation and refilling. Without a large moon, Earth's tides would be dramatically weaker, driven only by the sun, which contributes roughly half the tidal force the moon provides, despite being vastly more massive, simply because it sits so much farther away. The moon punches above its gravitational weight because of proximity, the same reason a small stone held close to your eye can block out a mountain in the distance. Hold the whole picture together for a moment. A companion world, formed from violence in Earth's earliest history, has spent 4.5 billion years quietly holding our planet's tilt steady, enabling the kind of stable seasonal cycle that life as complex as ours required to evolve in the first place. It drives our tides. It may have helped spark the chemistry of life along ancient shorelines, and it is drifting away from us, fingernails width by fingernails width, year after year, loosening its grip on a timescale too slow for any human to perceive directly, but inevitable all the same. The moon you glance at without thinking, hanging quietly in the night sky, is not decoration. It is one of the load-bearing pillars of the only stable climate humanity has ever known. We did not build the conditions that let civilization happen. We inherited them, from a wandering chunk of debris that settled into the one orbit capable of holding our entire planet steady. Thanks for watching, and I'll see you in the next one.